All right, I'm here to explain a few more of these integrals with you, and I've put up how we should have sorted them. Of course, there's always going to be multiple ways to solve something, but we want to go with the simplest way. So let's look at this first one. So I see this first one, and typically we want to do a u sub on a denominator, and that's not going to work here because the derivative of this is not the numerator. So instead, this is going to be a long division. So I'm going to leave you to that, but I'll just tell you about it. Same thing over here. But I do want to remind you of using, instead of long division, we can also use, oh my gosh, what is it called? My brain is broken. 1, 3, -7, 1, -1, synthetic division. Not -1, -4. So if I want to divide by a linear term that's x plus a constant, well, I can put the opposite of the constant out here. Here are my coefficients in descending order. If I was missing the x squared term, for example, I would have to fill in a 0. Drop down the 1, -4. I got that from multiplying. Add it up, I get -1. Multiply, I get a +4, leads me to a -3. Multiply, I get 12. This is my remainder of 13. So what this says is that this bit becomes my quotient. I can put my remainder over my divisor. So in the end, I'd have the integral from 2 to 5 of x squared minus x minus 3. So all of this we can just integrate with our basic rules, plus 13 over x plus 4 dx. Now this one, I would then need to do a u substitution with my ln. But since the derivative of this is just 1, I'm going to end up with, using my power rule, 1/3 x cubed minus 1/2 x squared minus 3x plus 13 ln of x plus 4. And I'm just using parentheses because from 2 to 5, that's always going to be positive. But if it wasn't, I would need to put in my absolute value bars. And then I'm going to evaluate that from 2 to 5. So I'll plug in the 5 and then subtract the output from when I plug in the 2. All right. This one, straight simplification. So I'm just going to rewrite that as x cubed over x minus 4 over x. That, of course, just becomes x squared, and then I can go on. Derivative rule, basic derivative rule here, basic derivative rule here, recognizing what we just talked about in the last video, that 1 over x squared plus 1 is an arctan derivative. So that's going to be arctan of 8 minus arctan of 3. This one I'm going to expand. So I'm going to simplify this using exponent rules. So this is going to be expand plus exponent rules. This one, cosecant cotangent. Well, this looks to me like derivative of cosecant. So I know that that's just going to be an integration rule. So this is integration rule, remembering my pst, or its converse with the cosecants. Straight integration here. This is a u sub. I can pick either cosine or sine to be my u because each one is the derivative of the other. Doesn't matter. X squared is like the derivative of x cubed, so that's a u sub. 2x is similar to the derivative of the inside here, so I get another u sub. Notice, if it's a square root times a factor, that's when I distribute, like here. Here I can distribute because I just have a square root of x. Here it's square root of more, so even if I tried to multiply this into the square root, I'm still not going to be able to evaluate it. This one, I'm going to expand and then evaluate. Down here, now we're getting into, this one is another U sub. Let's see, what were all my U subs? Stick. So I've got a K that's a U sub as well, and I can see that because this is really similar to the derivative of this. And now I'm getting into my geometry. This is one that we looked at in class. So if maybe you think about this with trigonometry, you try to make a triangle to describe it, but then you get stuck because it doesn't have any fractions to make me think of trig ratios. So really I want to think about this shape. Well, plugging in 0, I know I'm going to get 4. So just thinking about the shape of this graph, it's going to go through 0, 4. Plugging in -4, I'm going to go through 0. In between the rest of those is a quarter circle. So it's a quarter circle with a radius of 4. So this is geometry, just using my area under the curve. Over here, I can either use my antiderivative rules, because this is a pretty simple one, but it's also just the line 4x. And when I have a line that has no y-intercept, that becomes a triangle. Although this one, actually, because I move it over to 1 and then 5, I do have to think about it a bit more as triangle plus rectangle. Or instead, I could think that this area is going to be the same as, oh, am I about to say something that's true? No, I'm going to stop there. So I could think of my geometry making rectangle plus triangle. Here, geometry for sure, because those bounds are the same. So since those bounds are the same, and I know that sine x is an odd function, that means that sine x looks like this. Any area over here is canceled out by area over here. So even though we're continuing on a bit, it doesn't matter, because as much as I continue on, it's always going to be canceled out. This is just 0. And for sure, I'm going to want to use geometry here and use my shape, because x minus 7, absolute value of x minus 7, well, that's way down here. And I'm going between 6 and 8. So I'm going to have 2 equal triangles to add up. So I could find the area of one and just double it. And of course, this is a 1, 1. So my total area is going to end up being 1, because I'll have a half plus a half. So if you're stuck, try to think about geometry and how it can help you.